All right, this is 73 slides, but I think I can do it if I talk really quickly. This talk's called 2 + 2 = 10. There's a video game called Portal, and in this game, you're stuck in a laboratory and an evil robot's trying to kill you, and so you have to kill the robot. And there's a funny quote when you're trying to kill the robot.
2 + 2 is
10. In base 4, I'm fine.
All right, so if you didn't catch that, she said 2 + 2 = 10, and in base 4, I'm fine, which is a really funny joke. And there's 10 types of people in this world, people that think that joke was funny, and then people who just don't understand it yet. So I'm going to try to go ahead and explain it. So what is a number system? We have to start there. A number system is a collection of symbols combined with rules to facilitate their operation. Please explain like I'm 101, which is 5. So to do that, we're going to ask our friend, the count, to help us through this. So a really basic number system would be like base 10, which is decimal. So you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, and then 11, and then it goes on. You get the idea. What about like a base 2 number system? So that's called binary. So you have zeros and ones. You start with 0, you go to 1, and then you start to increment over. You introduce a new column for every single time that you reach the maximum value in that column. So you have 1, 0, and then for the next one we do 1, 1. Now we need to introduce a new column, and you start at 1, 0, 0. Same concept applies for every single number system. So why do we even need binary? It's really great at emulating with electricity, just on and off. I don't have enough time to get into quantum computing, which throws all of that idea out the window. But let's just talk really quickly about base 1. Base 1 is a unary language, which means that to describe 0, you just don't put anything. And then from there, you just increment every single one. Why would you even need base 1? It's actually a really great tool for realizing how long you've been in jail. So let's talk about base 16. So hexadecimal, you start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 10, 11. It's pretty obvious. So why would we need hexadecimal? It offers a more efficient way to store data than base 10 does. It's divisible by 2, 4, and 8 as opposed to just 2 and 5. And doubling things is really easy. 2, 4, 8, 16, 32. As you go on, you'll notice that all of these numbers are very common when it comes to pixel density, hard drive space, encryption techniques, and color ranges. Yes, exactly. So why do we even use a 10-digit number system? Well, it turns out we actually have 10 digits right in front of ourselves. And that's literally where the term digit came from. So wouldn't it be cool if we had 16 fingers? Well, we actually don't need to grow new fingers if you use the wrinkles between your joints and count through to 16. So back to the original joke, 2 + 2 = 10. It's entirely correct. In base 4, that is entirely true, and she was totally fine. That's it. All right.